Howdy. Just a basic read through physis.org. Swarm satellites unveil magnetic waves that sweep the outermost part of Earth's outer core. While volcanic eruptions and earthquakes serve as immediate reminders that Earth's insides are anything but tranquil, there are also other more elusive dynamic processes happening deep down below the Earth. Using information from ESA's swarm satellite mission, scientists have discovered a completely new type of magnetic wave that sweeps across the outermost part of Earth's outer core every 7 years. This fascinating finding, present the ESA's Living Planet Symposium, opens a new window into a world we can never see. Earth's magnetic field is like a huge bubble protecting us from the onslaught of cosmic radiation and charged particles carried by powerful winds that escape the sun's gravitational pull and stream across the solar system. Without our magnetic field, life as we know it would not exist. There is no gravitational pull on Earth, the sun. Understanding exactly how and where our magnetic field is generated, why it fluctuates constantly, how it interacts with solar wind, and, indeed, why it is currently weakening is not only of academic interest but also of benefit to society. In other words, you. For example, solar storms can damage communication networks and navigation systems and satellites and everything else. So while we can't do anything about changes in the magnetic field, hence the weather, understanding this invisible force helps to be prepared. Most of the field is generated by an ocean of superheated swirling liquid iron that makes up Earth's outer core 3,000 kilometers under our feet, acting like the spinning conductor on a bicycle dynamo. It generates electrical current and a continuously changing electromagnetic field. Or there's a plasmod inside Earth. And it's basically a living geoid. But let's continue reading. As a swarm mission, which comprises three identical satellites, measures these magnetic signals that stem from Earth's core, as well as other signals that come from the crust, oceans, ionosphere, and magnetosphere. Since a trio of swarm satellites were launched in 2013, scientists have been analyzing their data to gain new insight into many of Earth's natural processes, from space weather to the physics and dynamics of Earth's stormy heart. Let's watch this later. Measuring our magnetic field from space is the only real way of probing deep down to Earth's core. Seismology and mineral physics provide information about the material properties of the core, but they do not shed any light on the dynamo generating motion of the liquid outer core. But now, using data from the swarm mission, scientists have unearthed a hidden secret. A paper published in the journal Proceedings of the National Academy of Sciences describes of how a team of scientists detected a new type of magnetic wave that sweeps across the surface of Earth's outer core, where the core meets the mantle. This mysterious wave oscillates every 7 years and propagates westwards up to 1,500 kilometers a year. Nicolas Gillet from the Université Grenoble-Alpes, and lead author of the paper, said geophysicists have long theorized over the existence of such waves, but they were thought to take place over much longer timescales than our research has shown. Hence, the timeline issue. Many things are happening much more quicker than they thought, or many things happened much more recently than anyone thought. A repetitive pattern. Measurements of the magnetic field from the instruments based on the surface of the Earth suggested that there was some kind of wave action, but we needed the global coverage offered by measurements from space to reveal what is actually going on. We combined satellite measurements from SWARM and also other earlier German JAM mission and Danish Ørsted mission with a computer model of the geodynamo to explain what the ground-based data had thrown up, and this led to our discovery. The magnetic field is thought to be largely generated by an ocean of superheated planets. Owing to Earth's rotation, these waves align in columns along the axis of rotation. The motion and magnetic field changes associated with these waves are strongest near the equatorial region of the core. While the research exhibits magnetocoriolis waves near 7-year period, the question of the existence of such waves that would oscillate at different periods, however, remains. 7 years. It's the sun cycle, which is about. Is it? No. Doesn't fit. 6.5 years, 12 years cycle, 11. Probably it's about it's the sun cycle. The pole shift of the sun cycle, it switches. Probably, I don't know. Where we have been. Dr. Gillet added, magnetic waves are likely to be triggered by disturbances deep within Earth's fluid core, possibly related to buoyancy plumes. Each wave is specified by its period and typical length scale, and the period depends on the characteristics of the force at play. For magnetocoriolis waves, I haven't heard about magnetic Coriolis waves ever, but I'm totally uneducated. I'm just an average dude. So there are many things I haven't heard of. That's why I read stuff. The period is indicative of the intensity of the magnetic field within the core. Our research suggests that other such waves are likely to exist, probably with longer periods, but their discovery relies on more research. Our research ESA SWARM mission scientist Ilias Daras noted, this current research is certainly going to improve the scientific model of the magnetic field within Earth's outer core. It may also give us a new insight into the electrical conductivity of the lowermost part of the mantle and also of Earth's thermal history. You won't get a magnetic field without an electric current and vice versa. And here they are really nicely stacked on top of each other. So where was the video? Here. How does it work? Do we have sound? Yes.
Earth's magnetic field protects us from harmful particles in the solar wind. It extends deep into space, but is generated deep within our planet. By using satellites to measure fluctuations in the magnetic field, scientists are gaining new insights into Earth's interior. Unlike fixed observatories on Earth's surface, satellites can measure the magnetic field both globally and in great detail. The magnetic field is generated by swirling liquid iron in the outer core, which acts like a giant dynamo. Measurements from ESA's SWARM satellites have revealed a new type of wave motion mapped at the core mantle boundary. The wave oscillates around every 7 years, propagating westward at 1,500 kilometers a year. Combining these observations with a computer model of the geodynamo explains the source of magnetic field variations initially detected on the ground. Future measurements from space could help us understand more about the electrical properties of the lower mantle and about the magnetic field from deep in the fluid core. This research has important implications for our understanding of the geodynamo, the structure of the outer core, and the thermal history of Earth.
Okay. But 24th of May 2022, I made many weeks ago, at least it seems like many weeks, there has been this news about Earth's core, which is not fluid, it is, as they called it, superionic. Uh, I'm gonna search it. No, I finally found it 3 months ago. I will put a link below to this. Check it out. This is my created picture. It's also in the video, of course. And that's the news. Scientists discovered the Earth's inner core isn't solid or liquid. It's superionic. Hence, it is plasma. And I think it's interesting that despite this other research came out some time ago, they are still talking about the same old model about there's a metal core inside Earth and these kind of things. So I ask myself, haven't they read the news? How do they still repeat the same old paradigm about Earth's core here in this article? And this is really close to Kursk magnetic anomaly, the huge surface conductivity anomaly we have here in Scandinavia. Do we have Scandinavia here? No. And I will show it. This, that's the surface conductivity anomaly with the Kursk magnetic anomaly here down in Russia. And the red one, or the red ones, here is still one. And a few smaller here, I would say they are positively or northwards charged, and the blue ones are on the opposite side. And that's gone from the internet. You cannot reach the page anymore. I don't know if I have somewhere an example. No. But here you can see, go to web page. But it doesn't work. you will get an empty page. And these are my things what I do sometimes when I have free time. Thinking about weather patterns, how they work, how they spin. Low pressure, and that's the high pressure, which at the moment is gonna lose the battle. It seems like. Since the weather is gonna change. And here's also like screenshotting. I don't know what you people do in your free time. I do these kind of things. That's the polar cusp. That's the Birkeland current, which goes through Earth's core, which connects us to the sun. So we are watching at this region here, polar cusp, incoming solar wind particles. They go down, or in, or through, or however you want to put it. And this surface conductivity anomaly shape, which you can see here, as I was checking out the polar cusp thing on some page, I noticed this picture here, cusp reconnection observations. Fuselier van Tratner Wang Labro, ground-based low reconnection cells particle signatures, in situ spacecraft observations, remote particle signatures. Tratner et al. 2004. And then I noticed that there is a similarity in these two patterns. It's the opposite around, obviously, since we have the negative here in the middle, and here we have the positive, and they are on the side. It's just the opposite around, but it's the same pattern. And I think it's really interesting since the polar, what is it called? The Arctic Circle is somewhere here. So this is almost somehow within the polar vortex structure Birkeland current, where the heavenly pillar once stood. But anyway, I leave it here. I drifted off. I have no idea what I was talking about in the beginning of the video, but thanks.